Hello students, this is lesson U1A07A. In this lesson we are going to be working with slopes, and hopefully by the end of the lesson you should be able to say I can solve the slope of a line formed between 2 points, or find a missing coordinate if given one of the points and the slope value between those 2 points. What I want to do is I want to direct your attention to what's projected on the screen at the moment. These are all the different key concepts, okay, related to slope. What I have here is actually all the equations that you are going to be using for lessons 7A through 7D. Now that's a lot. What I want to do is just focus on just this, and in particular I just want you to focus on just this information right here. So the slope formula, or the slope between 2 points, you've all seen this before, having gone through Algebra 1. The slope between 2 points is simply the rise to run between 2 points. So if you have 2 points A and B, and you're asked to find a slope between the two, you're really tasked to figure out, well, how much vertical change there is and how much horizontal change there is. And if you know the ratio of the two, then that's your slope. All right, and the equation of a line can be expressed either as in the box that's shaded in pink there. There are 3 different ways, not 3 different ways. My mistake. Let me start over. The equation of a line, okay, by the way, that you were taught in middle school, is y equals to mx plus b, where m is the slope and b is the y-intercept. I'm not going to get into too much more detail as far as writing the equation of a line, and that will be left for a later lesson. But I'm going to move on here just so that we can discuss some of these ideas. Okay, so 2 lines, okay, or actually let's focus on this idea right here. So a horizontal line, okay, or if 2 points are on the same horizontal level, then it is described that the slope of that line is equal to 0. If 2 points are positioned one on top of one another vertically, where they have the same x-coordinates, this is described as a line with no slope, or undefined slope. Okay, so these 2 concepts here are really important if we're talking about the slope of a line that's horizontal versus the slope of a line that's undefined. Other concepts here, okay, 2 lines that are parallel, okay, will have the same slope, and then 2 lines that are perpendicular to one another will have negative reciprocal slopes. We will revisit these concepts at a later point in much more detail. But for now, these are the major concepts covered in this lesson. So why don't we take a look at some examples? Okay, so here we are. What you're tasked to do is to find out what is the slope of each of the lines that are given. So like I've said before, when you're finding the slope between 2 points, what you're doing is you're finding the rise and the run. So you're always moving from left to right. Keep that in mind, okay? You're always going from left to right. So you're moving from the left to the right. So vertically, okay, I noticed that there is a change of 6, okay? There's a change of -6. So delta y here is equal to -6. And then horizontally, there is a change of +3. So m here is equal to -6 over 3, or really it's just -2. Moving on. Again, you're always moving from left to right. So here we're going up, and then we're moving over. So I noticed that there's a positive change of 1, and then there's a horizontal change of 2. So m is equal to 1/2. Moving on. Again, you're always moving from left to right. So again, left to right. So the vertical change is 3. The horizontal change is 3. M is therefore 3 over 3, or m is 1. Again, you're moving from left to right. You're always going from left to right. So I noticed that there is a horizontal change of 1 and a vertical change of -2. So therefore m is equal to -2. It's actually the same answer as question number 1. All right, moving on. Find the slope of the line through each pair of points. So this is the part where we need to apply this slope formula verbatim. So keep in mind, what is the slope formula? Slope formula is y2 minus y1 over x2 minus x1. So a trick, or if you want to call it a trick, is I often tell students, if you get confused, why don't we just label these as x1, y1 and x2, y2 so that you can keep track of everything. So knowing this, okay, we perform the necessary substitution. This is -1 minus -20 all over 10 minus 20. And this is going to turn into positive 19 over negative 10. Because the negative sign can be moved around, we can actually move this and say this is negative 19 over 10. Okay, moving on, question number 6. And again, you can apply that trick, x1, y1, x2, y2. It really doesn't matter what you call x1, y1 and what you call x2, y2. I just happen to, like calling the first coordinate there x1, y1. So m in this case is equal to, again, 5 minus 8 over -8 minus -18. And if I perform the necessary computation here, this is -3 over 10, or -3/10. You can move that negative symbol anywhere you'd like. Again, moving on here, m is equal to, and again, after a while of labeling, you should be able to be familiar with not labeling. It's sort of like, gaining enough confidence and then later on not needing to depend on that tactic in finding out what the slope is. So this is really -1 minus 7 all over 11 minus -20. And if you perform this necessary computation, this is -8 over 31. Moving on, m here is equal to 14 minus 7 all over 16 minus 11. So this is equal to 7 over 5. Moving on. All right, so now we got to find out what the values of x or y is so that the line through the points has the given slope. So for question 9, it says here 8, y and -6, 2 will have a slope of 0. So how is this possible? Well, we just apply the slope formula like we normally would. I'm going to call this x1, y1, x2, y2, and check this out, right? I'm going to do 2 minus y all over -6 minus 8. Now this ratio here is equal to the slope. But what's the slope value? Oh yeah, it's 0. It's given to us in the problem here. So if I have 2 minus 8, this becomes 2 minus y all over -14 is equal to 0. And if I multiply both sides by -14, I'll end up with 2 minus y is equal to 0. Or really, y is equal to 2. Moving on. Again, very similar, okay? I can call this x1, y1, x2, y2. Again, after a while of doing this, you should be able to successfully approach this without having to go through making those labels. But I'm going to start with these first two examples. Y minus 4 all over 1 minus -5 is equal to -11 over 6. This is where the algebra gets a little hairy. Okay, so I have y minus 4 over 6. So y minus 4 all over 6 is equal to -11 over 6. Here we're going to cross multiply. When we cross multiply, I'll end up with 6 times y minus 4 is equal to 6 times -11. And if we perform the necessary distribution, we'll end up with 6y minus 24 is equal to -66. Let's add over 24. We end up with 6y is equal to 42. Okay? Or y is simply equal to 7. Divide both sides by 6, we end up with y equal to 7. And then moving on. I'm not going to do every single one of these just because it gets very repetitive, okay? Just like when I assign questions to you guys, I tell you to do only the odd questions, just because I recognize that, some of these do get, rather repetitive. So I'm going to skip ahead and do question 13 because this is the one question that I did not get to, which is an undefined slope. So if I have 2 1/2, 3 5/8, and we have x comma 2, and this has a slope that is undefined, right? So what does it mean to have an undefined slope? And a line with an undefined slope means that the two coordinates are stacked one on top of the other. Just keep that in mind, right? Two lines, or 2 points, okay, that are stacked one on top of the other vertically. What will be true about their x coordinates? Will they be the same or will they be different? If you're thinking they will be the same, you're absolutely right. X is equal to 2 and 1/2. That's all it is, right? And this is also true if you think about it, right? If I have 3 and 5/8 minus 2 all over 2 and 1/2 minus x, right? Regardless of what the numerator is, it doesn't matter. If ever we divide by 0, which is what's going to happen in the denominator, what has to be x in order for the denominator to go to 0? It would have to be 2 and 1/2. Similarly, another way of interpreting this problem right here, we've solved that y is equal to 7, right? Which is I'm sorry. This question is what I wanted to talk about. Question number 9. Notice that the slope here is 0, right? So for a line that has slope of 0, what has to be true about the orientation of the 2 points? What has to be true about the y coordinates? So we could have actually done question 9, okay, thinking about this, right? We could have solved it logically in this way. For a line to have a slope of 0, the y coordinates between the 2 points must be the same. So logically, for number 15, right, without having to do any work at all, what would the answer be for number 15? For number 15, the y coordinate here has to equal to 6/7, right? All right, it is as simple as that.